The Science and Engineering Learning Community is a group of high-achieving students from Glenbrook South that are really interested in seeing the connections and exploring the connections between their science classes and engineering. The Science and Engineering Learning Community affords incoming students an opportunity to explore passions in both science and engineering in a very integrated way. Students have an opportunity to take a 4-year sequence of paired courses between science and engineering, and this culminates in a capstone pair of courses, which would be an AP Science course and the Engineering Design and Development course.
Yeah, the idea behind the SELC is we offer a 4-year sequence of engineering courses. So we start out with Introduction to Engineering Design and Project Lead the Way. They're also taking physics as a freshman, and it is a physics course designed for the SELC. And then they would move on to Principles of Engineering, which is also paired with chemistry.
Junior year then, Digital Electronics is the engineering course paired with the biology course. And then as a senior, seniors would take the capstone EDD or Engineering Design and Development course and an AP Science course.
I'm Mike Cindy, or Mr. Cindy. I am a Project Lead the Way teacher here at Glenbrook South. This class you're in right now is called Project Lead the Way Introduction to Engineering Design. And ultimately this class we do a lot of 3D modeling, 3D printing, and introduction to coding. They partner where we tie in with a physics class. So we use an Arduino board, which is a microcontroller, and we do a lot of coding with that. So right now what they're doing is their homework assignment was to carve a pumpkin, and now they're putting Arduino inside it so that it can make music or sounds, etc. for Halloween. They'll get an introduction to all the tools and equipment in the makerspace, so how to use a laser engraver, how to use a table saw, bandsaw, those types of things. A lot of introduction to coding. So we use an Arduino board for all 4 years of high school, and they get an introduction to it this year and learn how all the different tools and sensors work for that.
My name is Bobby Cowie, and I teach the Honors Physics SELC course. We integrate with the engineering course. So the decision we made was to start the freshmen in this program with physics, it being a more foundational science, and we try to link and integrate a lot of the ideas and concepts that we do in here. So some of the principles, for example, right now we're working on circuits, and the kids apply those in their engineering course. So in their engineering course they're using Arduinos and circuit boards, and they are kind of seeing the application of their science class with that engineering class. We specifically design it so that they can kind of see the marriage between those concepts and applications. Because we have that engineering component, we do some things that the other physics courses at the school don't do. I really ask the students to think about evidence-based reasoning. So it's less of me telling the students what they need to know and more of them doing hands-on experiments, kind of use their own reasoning from that evidence to derive the physics. And that's a really important skill going forward. That's what's going to help them have those critical thinking skills, those deduction skills. And I think this course does a nice job of helping them do that.
My class is chemistry. It involves all the things that we would study in any chemistry class, but we try to put a few more engineering applications. So my background is as a chemical engineer, so I'm able to bring some of that chemical engineering ideas to my chemistry course and implement how does this chemistry look like when it's in industry. So for instance, later today, one of the things we're going to do is be introduced to coding. So we're going to learn how to code a Google spreadsheet to do some chemistry calculations for us to solve a forensic puzzle about an airplane crash. So they're going to get like a leg up on the rest of the competition when they go off to college because they've had some of the stuff that's going to be covered in the first years of engineering.
I'm Mr. Schmidgall, and I teach the Principles of Engineering class in PLTW.
My name is Justin Zumo, and I teach a lot of the Project Lead the Way courses here. This year I'm blessed to have the opportunity to work with the CELC students in the POE class.
So we are using the Lego platform to do design challenges that perform a specific task. So right now they have to program a robot to pick up a mass and move it through a course that has sensing capability as well. In our class we use physics a lot to build our robotic systems, but we're integrating with chemistry in order to perform chemistry experiments that are automated and programmed by the students themselves. And it runs the experiment and puts out an answer. We build upon what they're doing now in the design process, and we move from that to the Arduino, and then they put all that together to actually monitor the experiment they're performing, and then run motors or other actuated devices in order to complete the tasks. So we do soap mixing, heat capacity calculations, we do thermal conductivity, and we also have it titrate an acid at the end of the year from beginning to end, all by itself, of what they've designed, built, and tested.
So one of the things that I love to focus on, my passion, is robotics. So whether it's the Lego NXT or the VEX equipment that we use in the Project Lead the Way, Principles of Engineering course is extremely hands-on. The kids get to interact with these principles that we're talking about in the classroom, and then they get out in the makerspace and they get to build and tinker and experiment and try different things, and it really drives home that learning. By teaming up with very rigorous curriculum and then allowing them to find that gray area of, I know how to do this, but I don't know how to do that, and really pushing their boundaries. Getting them into that mindset of, it's okay to fail, and it's perfectly fine if I try something new and it doesn't work out for me. That's that learning experience, and that's what helps build those connections as they go further into the profession.
Okay, so this is the third year in the sequence, and so in my year they're taking this course, which is digital electronics. Now, the course itself, topics-wise, is a history of control and control with the microcontroller. Microcontrollers in a more kind of integrated package are used throughout all kinds of engineering, and I think as things get more and electronic, you ask the question of, okay, like is it important to know that sort of thing? And indeed it is. This year is where we kind of look at the history of that, do a little bit more in-depth look at how we can analyze circuits, and then we get into the digital world, and that is all digital control, and that's the background of this course.
I'm Ms. Pupala, and I teach the SELC Biology Honors course. In our course, we do an integration between digital electronics and biology. We focus a lot on the principles of biology, how the natural world works, and we try to find order and look at how biology and the biological world is optimized in the same way that you could a machine or an electronic device. Students tend to build all of their own labs, they identify variables, and they put their own questions together. Students who are interested in engineering are going to find this as a really good integration of biology and engineering. If you are interested in molecular biology, bioengineering, biomedical engineering, you'll find that we do a lot of core principles having to do with that. We see biology from a more skills-based perspective. This is a really great course to take after you've had physics and chemistry too. We can look at the natural world on its smallest levels as well as on a really, really big level by the end of the year.
So this is the capstone class. Students have been waiting for this class for 4 years. The first 3 classes, they build a great skill set. Now it's applying all those skills to solve a real world problem. Their goal is to take a problem in the world and try to create a solution to that. So they go through and look at patents, they go through, look at previous solutions, and then ultimately create their own solution. They work that solution not only with themselves and their classmates, but with a engineer or a panel of engineers outside of school. And then ultimately, they create their solution and present that to the panel of engineers in the springtime. You know, it really is a hands-on application, so it replicates exactly what they do senior year of college. And here's their chance to go through that with their solution.
Anybody who is creative and wants to be able to have a means to kind of release that should take mind in joining this program.
The program as a whole has opportunity to have this maker mentality. So the biggest thing is getting them to become better problem solvers, and then ultimately give them a chance to go out there and solve problems in the real world.
I love being able to learn something on paper and then take what I learned and actually make something out of it. And I loved having, oh hey, I can write out the math problem here of how the circuit should perform, and then I can go out and build it.
I didn't get a lot of this until later in college, and I think that's a disservice to the students, and I think that that's one of the aspects we are focusing on is hands-on, get in there and do it.
So it's really an exposure to the experience of it, the design from scratch idea, which is challenging, and whether you can stick with a problem through it becoming, achieving a real solution, which is not easy to do.
This program focuses a lot on problem solving, and a lot of engineering and science fields require that like teamwork. So this class and this program helps you build those skills of teamwork and just asking yourself questions and figuring things out on your own.
And if you like building, fabricating, hands-on, using tools, 3D designing and printing. If you love to see your ideas come to fruition, this is a place to do that.
The community is very supportive of each other. The teachers, for example, they always try to find new opportunities for you.
So these students are very passionate about STEM in general and really passionate about problem solving. And being in this program allows you to be around those like-minded students.
It's not just a classroom of students, it's that, but it's also you talking to an engineer and you being able to kind of release what you've wanted out of this program, and that's what you get.
If you're a student who's eligible and you have a passion for building things, thinking about how the world works, designing solutions, this is something you should seriously consider because it offers opportunities that you don't get in other programs at GBS.
Those who definitely have a passion for the STEM fields, and particularly I would say the connections between science and engineering, this is a rich opportunity.
Why shouldn't you join this class? It's not just for engineers, as funny as it sounds. This is for makers, and we have a class saying that's everybody's a maker. And so if you just have any kind of passion in building things or solving problems at all, you can find a way to make this class work for you. There's just so many ways you can make this your own, and I think anybody could enjoy this.